Another method to find the mesh currents in a given problem. It is a easy method. So by inspection method, first check the problem. It is a pure DC network problem. We are having DC resistance only here in the entire circuit. We have a resistance and DC voltage source. So this is very easy. You can directly find out the answer using inspection method. So I'm going to write a by inspection method. You can write one matrix here. You can write matrix. So I'm writing matrix by inspection method. I am writing a matrix. So if you are lucky that if they ask like this problem without mistake, you can immediately write. So remember, diagonal elements are okay. This is resistance matrix. This is current matrix. This is voltage matrix. Okay. So in this, okay, first element is sum of resistance in mesh 1. What is the sum of resistance in mesh 1? In the mesh 1, 10 plus 20. So it is 10 plus 20 is 30. Common to mesh 1 and mesh 2. Common to mesh 1 and 2, you have to write minus. So minus 20. Common to 1 and 3. Common to mesh 1 and mesh 3 is minus 10. Minus 10. Okay. So I'll rewrite once again. It's not, I'll write a little bit smaller. 30 minus 20 minus 10. And after that, first you write three unknown variables are currents. I1, I2, I3 are the currents. And in mesh 1, in the clockwise, if you write in this clockwise, we'll get first minus to plus, minus to plus. So while writing KVL, please see here, while writing KVL, first here we got minus, no? While writing KVL, minus 10 is there. If you bring it to right side, it becomes positive. So if you get in while writing KVL, the minus to plus means left side uh, minus 10 will be there. Right side after bringing right side, it becomes plus. So that is the equation number 1. And second, while writing KVL for mesh 2, okay, this is common to 2 and 1. This is 1 1 1 2 1 3. Next to 2 1 2 2 2 3. Okay, second element 2 1. Common to 2 and 1 is same as 20. So whatever you got here 20, you have to write minus 20. Sum of resistance in mesh 2, 20 plus 20 plus 10, it is 50. Common to 2 and 3, it is minus 20. Minus 20. Again now, common to 3 and 1, 3 1 3 2 3 3, 3 1 3 2 3 3. 3 to 1, common to 3 to 1 is minus 10. Common to 3 to 2 is minus 20. 3 to 2 is 20. And sum of resistance in mesh 3, 20 plus 20 plus 10 is 50. And is there any voltage source in the mesh 2? There is no voltage source in the mesh 2, it is 0. And is there any voltage source in the mesh 3? In the mesh 3, we have 5 volts. And this 5 volts, while writing KVL in the clockwise, first we got plus to minus. So plus to minus means there we got, while writing KVL, plus we got 5. If you bring it to right side, you'll get minus 5. If you are using another type of notation where if you are using minus to plus as positive, rise in voltage as positive, everywhere you throughout you multiply it by negative. You'll get minus, same three equations only you are going to get. Okay. You make it throughout you can multiply it by negative, you'll get the same answer. Because you have to bring all the terms after the equals means it becomes plus 30 becomes minus 30, this becomes plus 28, so this becomes plus I3 and this becomes minus 10. So everything throughout we can multiply it by, and after that solving the same three equations you are going to get I1 I2 I3. Take the equation mode, type 30 minus 20 10 like in the calculator that I already explained. Okay, you can do once again. So what you can do is go to equation mode 5 to select the unknown variables, equation number 2. So there you enter 30 is equal to, then minus 20 is equal to, minus 10 is equal to, 10 is equal to, minus 20 is equal to, 50 is equal to, minus 20 is equal to, 0 is equal to, minus 10 is equal to, minus 20 is equal to, 50 is equal to, then minus 5. Then if you click is equal to, you'll get x is equal to 0.55. Okay, then y is equal to 0.26, z is equal to 0.11. So what you can do is, if they ask, please remember, if they ask pure DC network, okay, voltage source and resistance only, then directly you can use this. This is voltage matrix. It's a voltage matrix. So resistance matrix multiplied by current matrix will give you voltage. So I1, I2, I3 in mesh currents, I1, I2 are three unknown variables. I1, I2, I3, three meshes. So I1, I2, I3. In the resistance matrix, first element is sum of resistance in mesh 1. Common to, this is 1, 1. So 1, 1 means belongs to 1 only. In the mesh 1, how many resistance are there? 1, 2. Common to 1 and 2. 1, 3. Common to 1 and 3. And this is 2, 1, 2, 2, 2, 3. Common to 2 and 1. 2, 2. Exclusive mesh 2 only. So sum of resistance in mesh 2. 2, 3. Common to 2 and 3. This is 3, 1. Common to 3 and 1. 3, 2. Common to 3 and 2. 3, 3. 3, 3 means exclusively for 3. Mesh 3. Remember, only this diagonal element. Only this diagonal elements are positive. Sum of resistance in mesh 1, mesh 2, mesh 3. Sum of resistance in mesh 1, sum of resistance in mesh 2, sum of resistance in mesh 3 are positive. All other are negative. Okay. And common to know, they are negative values. Whatever common to 1 and 2 is same as 2 and 1. Common to 1, 3 is same as common to 3 and 1. Common to 2 to 3 is same as common to 3 and one more thing, while rating voltages in the clockwise, if you get clockwise minus to plus, that becomes opposite, plus here. And here plus to minus is there. So plus 5 means you will get minus 5 here. So what you can do is, if they ask this type of problem without a dependent source, dependent source also should not be there. Okay, only voltage source. Okay, voltage source and resistance. If they ask this type of problem, directly by inspection method you write. After that, there will be a marks for this steps also. So what you can do is, you can do reverse. So multiply matrix, this R and I you multiply 30 I1. See here we got this equation. First you leave some space in the exam. This much space you leave here. Write this matrix and do the reverse. So 30 I1 minus 20 I2 minus 10 I3 is equal to 10. 30 I1 minus 20 I2, 30 10 I3 is equal to 10. So second equations, how to write? Multiply this, minus 20 I1, 50 I2 minus 20 I3 is equal to 0. Third equation, minus 10 I1 minus 20 I2, 50 I3 is equal to minus 5. So you can write from the inspection method what we got matrix. You do the reverse and you can write three equations, because in the scheme of evaluation there is a marks for writing KVL also. First you write this. First you leave some space here. First write this matrix. After that go back and write applying KVL mesh 1. Directly you can write this equation. This indicates that sum of resistance in mesh 1 into I1. From this drop you have to subtract opposite current drops. 20 I2 and 10 I3 you have to subtract. And again in the mesh 2, 50 I2 is the actual voltage in the mesh. And you have to subtract 20 I1 and 20 I3, which are opposite currents. And in the mesh 3, that 50 I3 is a clockwise current, and 10 I1 and 20 I1 are opposite current drops. You have to subtract, and voltage is minus 5. So you can use this method also. Remember, this is applicable only for if it is uh, independent voltage source and resistance only. If there is a dependent source, don't follow this. If there is a AC source also, don't follow this. Only if they ask this independent voltage source and resistance, you can follow this method. Thank you.